CL2 cable is a communication wire rated for dry, indoor use and should not be used outdoors without additional protection. Sunlight resistance refers to the cable's ability to withstand ultraviolet radiation, while weather resistance also includes protection against moisture, chemicals, and temperature extremes. To address the red tag issue, firstly consult with the manufacturer of the CL2 cable used to confirm whether it has weather resistance properties. Some manufacturers may offer CL2 cable with both sunlight and weather resistance ratings. Secondly, if the manufacturer confirms that the cable lacks weather resistance, consider enclosing it in conduit, a cable tray, or other protective covering to shield it from the elements. Thirdly, install new outdoor rated wire that meets all the requirements of NFPA 70 National Electrical Code for exposed wire in outdoor environments. Guidelines for outdoor wire installation include using cables with a minimum rating of UF, underground feeder, UVX, underground feeder with sunlight resistance, or use underground service entrance. Ensure cables are appropriately supported, secured, and protected from physical damage. Avoid running cables directly on the ground or in areas with excessive moisture. Terminate cables in weatherproof enclosures or junction boxes. Additional tips include requesting a re-inspection once the issue has been resolved to clear the red tag. Document all corrective actions taken to demonstrate compliance with code requirements. Consider consulting with a licensed electrician if unsure about the appropriate cables or installation methods. Elaborate. It is crucial to differentiate between sunlight resistance and weather resistance when selecting cables for outdoor applications. Sunlight resistance primarily addresses the degradation caused by ultraviolet radiation from the sun. This type of resistance is essential for cables exposed to direct sunlight, as prolonged exposure can lead to the breakdown of the cable's outer jacket, resulting in cracking, discoloration, and eventual failure. However, sunlight resistance alone does not provide comprehensive protection against other environmental factors. Weather resistance, on the other hand, encompasses a broader range of protective properties. In addition to ultraviolet resistance, weather-resistant cables are designed to withstand moisture, chemicals, extreme temperatures, and physical abrasion. This makes them suitable for outdoor environments where cables are exposed to various elements that can compromise their integrity and performance. When an electrical inspector issues a red tag due to the use of CL2 cable lacking weather resistance in an outdoor application, it indicates a non-compliance with safety standards and electrical codes. CL2 cable is specifically intended for indoor, dry locations and is not engineered to endure the harsh conditions present in outdoor environments. Using CL2 cable outdoors can lead to premature cable failure, electrical hazards, and potential safety risks. Therefore, it is essential to take immediate corrective actions to address the red tag issue and ensure compliance with applicable codes and regulations. To effectively resolve the red tag situation, firstly, verify the cable's specifications by consulting with the manufacturer. Contacting the manufacturer of the CL2 cable provides an opportunity to confirm its properties and limitations. Some manufacturers may offer CL2 cables with enhanced features, including both sunlight and weather resistance. Requesting detailed product information and technical data sheets from the manufacturer can help determine whether the existing cable meets the requirements for outdoor use. If the manufacturer confirms that the CL2 cable lacks weather resistance, consider alternative solutions to protect the cable from environmental factors. Secondly, enclosing the CL2 cable in a conduit or cable tray offers a practical way to shield it from moisture, chemicals, and physical damage. Conduit provides a rigid, protective barrier around the cable, preventing direct exposure to the elements. Cable trays offer a more flexible solution for routing and supporting cables, while also providing some degree of protection. When selecting conduit or cable trays, ensure that they are suitable for outdoor use and made from materials that can withstand the environmental conditions present at the installation site. Thirdly, replacing the CL2 cable with an outdoor rated cable is the most reliable and code-compliant solution. Outdoor rated cables are specifically designed and tested to withstand the rigors of outdoor environments, ensuring long-term performance and safety. Refer to NFPA 70 National Electrical Code for guidance on selecting the appropriate type of cable for outdoor installations. The National Electrical Code specifies minimum requirements for cables used in various outdoor applications, taking into account factors such as exposure to sunlight, moisture, temperature variations, and physical stress. When choosing an outdoor rated cable, consider cables with a minimum rating of UF, underground feeder, UVX, underground feeder with sunlight resistance, or use, underground service entrance. UF cable is designed for direct burial in the ground and is resistant to moisture, chemicals, and physical damage. UVX cable offers enhanced sunlight resistance, making it suitable for applications where the cable is exposed to direct sunlight. Use cable is commonly used for underground service entrance applications and is designed to withstand harsh environmental conditions. In addition to selecting the appropriate cable type, it is essential to follow proper installation practices to ensure the long-term reliability and safety of the outdoor wiring system. Support and secure cables adequately to prevent sagging, abrasion, and physical damage. Avoid running cables directly on the ground or in areas prone to water accumulation. Terminate cables in weatherproof enclosures or junction boxes to protect connections from moisture and corrosion. Furthermore, it is advisable to consult with a licensed electrician to ensure that the outdoor wiring installation complies with all applicable codes and regulations. A qualified electrician can assess the specific requirements of the installation site, recommend suitable cable types and installation methods, and perform the work in a safe and professional manner. After completing the necessary corrective actions, request a re-inspection from the electrical inspector to clear the red tag. Provide documentation of all work performed, including cable specifications, installation details, and any other relevant information. This will demonstrate compliance with code requirements and help ensure that the outdoor wiring system meets safety standards. To further clarify the types of cables, firstly, UF cable, or underground feeder cable, is a type of electrical cable designed for direct burial in the ground. It is commonly used to supply power to outdoor lighting fixtures, pumps, and other equipment. UF cable is constructed with a durable, moisture-resistant jacket that protects the conductors from water, chemicals, and physical damage. It is also sunlight resistant, making it suitable for applications where the cable is exposed to direct sunlight. UF cable is available in various sizes and configurations to meet different load requirements. Secondly, UVX cable, or underground feeder cable with sunlight resistance, is similar to UF cable but offers enhanced protection against ultraviolet radiation. It is specifically designed for applications where the cable is exposed to prolonged sunlight exposure. The outer jacket of UVX cable is formulated with additives that resist degradation from ultraviolet rays, ensuring long-term performance and reliability. Thirdly, use cable, or underground service entrance cable, is used to bring electrical power from the utility company's transformer to the customer's service panel. It is typically installed underground and is designed to withstand harsh environmental conditions. Use cable is constructed with a robust, moisture-resistant jacket and is available in various sizes to accommodate different service entrance requirements. In addition to these common types of outdoor rated cables, there are other specialized cables available for specific applications. For example, tray cable, or TC cable, is designed for use in cable trays and is resistant to chemicals, oil, and abrasion. Landscape lighting cable is specifically designed for low-voltage landscape lighting systems and is suitable for direct burial in the ground. When selecting a cable for a particular application, it is important to consider the environmental conditions, load requirements, and applicable codes and regulations. Consulting with a licensed electrician or electrical engineer can help ensure that the correct cable type is chosen and installed properly. Moreover, proper cable installation practices are crucial for ensuring the safety and reliability of outdoor wiring systems. Firstly, always energize the circuit before working on any electrical wiring. Secondly, use appropriate tools and equipment for cutting, stripping, and terminating cables. Thirdly, follow manufacturer's instructions for cable installation and termination. Fourthly, support and secure cables properly to prevent sagging, abrasion, and physical damage. Fifthly, avoid running cables directly on the ground or in areas prone to water accumulation. Sixthly, protect cables from sharp edges and abrasive surfaces. Seventhly, terminate cables in weatherproof enclosures or junction boxes. Eighthly, ground all metal enclosures and equipment properly. Ninthly, inspect the wiring system regularly for signs of damage or deterioration. Tenthly, replace any damaged or deteriorated cables promptly. By following these guidelines, you can ensure that your outdoor wiring system is safe, reliable, and compliant with applicable codes and regulations. In summary, addressing a red tag issue related to CL2 cable used outdoors requires a thorough understanding of cable properties, code requirements, and appropriate installation practices. By consulting with the manufacturer, considering alternative protection methods, and replacing the cable with an outdoor-rated option, you can resolve the issue and ensure the safety and reliability of your electrical system. Remember to always prioritize safety and consult with qualified professionals when working with electrical wiring. Remember that understanding the terminology is very important. Sunlight resistance means the cable can withstand the effects of the sun's ultraviolet rays. Weather resistance means the cable can withstand not only the sun's rays, but also moisture, temperature changes, and physical wear. In situations where cables are exposed to the elements, weather-resistant cables are crucial for maintaining safety and reliability. To further extend on cable installation, firstly, always ensure the power is off before starting any electrical work. Secondly, use the correct tools to cut and strip the cable, avoiding damage to the conductors. Thirdly, when running cables through walls or floors, use appropriate bushings or grommets to protect the cable from abrasion. Fourthly, secure cables with staples or cable ties, ensuring they are not too tight to avoid damaging the cable. Fifthly, maintain proper spacing between cables to prevent overheating. Sixthly, label all cables clearly for easy identification. Seventhly, test the installation to ensure proper functionality and safety. In addition to cables, understand conduit types. Firstly, rigid metal conduit, or RMC, is a heavy-duty option that provides excellent protection against physical damage and corrosion. Secondly, electrical metallic tubing, or EMT, is a lightweight option that is easy to bend and install. Thirdly, flexible metal conduit, or FMC, is used in tight spaces or where flexibility is needed. Fourthly, liquid-tight flexible metal conduit, or LFMC, is used in wet locations to protect against moisture. When selecting conduit, consider the environment and the level of protection needed. Use appropriate fittings and connectors to ensure a secure and watertight connection. Ground the conduit properly to prevent electrical hazards. Furthermore, to select a cable, consider the amperage of the circuit. The cable must be able to handle the maximum current draw of the circuit. Consult the National Electrical Code, NEC Table 310.15b16 for ampacity ratings of different cable sizes. Consider the voltage drop in the circuit. Long runs of cable can experience voltage drop, which can affect the performance of the equipment being powered. Use a larger cable size to minimize voltage drop. Consider the environment where the cable will be installed. Outdoor cables must be weather resistant and sunlight resistant. Cables installed in wet locations must be suitable for wet locations. Consider the type of equipment being powered. Some equipment requires shielded cable to prevent electromagnetic interference. When in doubt, consult a licensed electrician to ensure the correct cable is selected and installed properly. Selecting the right wire gauge is crucial for safety and performance. Overloaded circuits can lead to overheating and fire hazards. The National Electrical Code provides guidelines for wire gauge based on the amperage of the circuit. For example, a 15 amp circuit typically requires 14 gauge wire, while a 20 amp circuit requires 12 gauge wire. Always check the ampacity rating of the wire before installation. When running long distances, use a larger wire gauge to minimize voltage drop. Voltage drop can reduce the efficiency of the equipment being powered. When working with electrical wiring, always prioritize safety. Firstly, turn off the power at the circuit breaker before starting any work. Secondly, use insulated tools to prevent electric shock. Thirdly, wear safety glasses to protect your eyes. Fourthly, never work on electrical wiring in wet conditions. Fifthly, if you are not comfortable working with electrical wiring, hire a licensed electrician. In addition to cable selection and installation, it's important to understand other electrical components. Firstly, circuit breakers protect circuits from overloads and short circuits. Secondly, ground fault circuit interrupters, or GFCIs, protect people from electric shock. Thirdly, surge protectors protect electronic equipment from voltage spikes. Fourthly, lighting fixtures provide illumination and can be controlled by switches or dimmers. Fifthly, receptacles provide a connection point for electrical appliances. Understanding these components is essential for designing and maintaining a safe and efficient electrical system. Furthermore, always follow local electrical codes and regulations. Electrical codes vary from location to location, so it's important to be aware of the specific requirements in your area. Obtain necessary permits before starting any electrical work. Have your work inspected by a qualified electrical inspector to ensure compliance with code. Working with electricity can be dangerous, so it's important to take all necessary precautions. By following safety guidelines and consulting with qualified professionals, you can ensure that your electrical system is safe, reliable, and compliant with code.